So welcome to this Megger studio. We have moved out now to KTH, Royal Institute of Technology in Stockholm. We do this as the second part of the digital substation series that we do the interviews with different people. And today I have the honor to have Professor Lars Nordström here.
Oh.
Welcome to this studio.
Thank you very much. Really happy to be here. Or you brought the studio here, actually.
Yeah, actually we did, and yeah, it's a pleasure to be here at the campus. You can sense all the positive atmosphere of young students being here and learning a lot of new stuff. So that's interesting.
Yeah, well, you're very welcome here.
Yeah, thank you so much. Can you first tell a little bit about yourself, Lars?
Sure. As you said, I'm a professor here at KTH. I work at the Division of Electric Power and Energy Systems. So what I do here is I teach and I do research on topics related to power systems. Specifically in my case, let's call them digital power systems. Anything related to control, automation, protection, and these kinds of matters, which are of course critically important for operating a power system.
Yeah. And it's a large subject.
It's a large subject, and I'm also happy to say that it's a popular subject. I mean, many students are interested to see the intersection between power systems related, of course, to sustainability and electrification, and also digitalization and future technologies and so on. So it's a really good place to be.
I'm very happy to hear, because we have seen a resource, all knowledge fading out from the industry in the last couple of years. So that's very glad. I'm glad to hear that. So tell a little bit about KTH and this campus and so on.
A few words about us.
Yes.
KTH is the largest technical university in Northern Europe here. We've been around for around 200 years. And we educate students and we do research basically across all engineering topics, from biochemistry, mechanical engineering, electrical engineering, of course, architecture, etc., etc. And we have around 13,000 students and a couple of hundred professors, and of course thousands of research staff and PhD students.
So it's quite large. Is it the largest in Sweden, Nordics, or?
In the Nordics, I think we're the largest, and we're also happy to be reasonably well ranked in the international top lists and so on, specifically in the electrical engineering topic, actually. So,
good, that's great. So we're here to focus on the digital substation, IEC 61850, since that's one of your favorite subjects.
It is indeed, yeah.
So first, I have a question here. How do you describe IEC 61850 in a few words?
Oh, well, keep in mind that I'm not a practitioner. I'm a university professor.
Yes.
So when I look at IEC 61850, I see it as a, could I call it encyclopedia? It's like or Wikipedia is perhaps the more modern term. It's a good place to go when I want to know more about how practitioners do when they build digital substations. Of course, I have some idea of it myself. But it's really it's a treasure chest when you want to figure out how things should be built, how they are built, and what can be done with it. So it's sort of a rule book, I guess. Then, of course, I don't know if everyone plays by the rules. That's another matter. But IEC 61850 is really a great resource for anything related to digital substations. Really.
Is there something which is not? Is there some common misunderstandings, would you say, that comes into this? Or
well, I mean, it is a large resource, and I guess that many, both practitioners and also here in academia and other places, you can't cover all of it. So it's quite easy that you perhaps draw the conclusion it's like a communication protocol. It's there to solve the communication between two units. And of course, it does that too, but it's only a small part of it.
I think that's a very good summary. That's what we hear as well. So, in your view, is there any difference between a digital substation and an IEC 61850 substation?
Sure. I mean, the digital substation is a more generic term, and I've seen many examples of like pilots together with utilities and power companies that are digitalizing or modernizing their substations with various remote IOs, communication buses, etc., which are not at all 61850 based. I mean, you could look at any industry, there's many other communication solutions you could do. So you could build a digital substation with some other setup.
Yeah.
So the IEC 61850 is one flavor. However, it's the collected knowledge which has gone into designing the 61850 standard is, of course, it gives a better trust that you're not on your own when you're experimenting with the digital substation.
Yeah, and that's of course important that you follow, or more easy, I guess. You can collect the knowledge around the world and so on if you follow something like that. Right?
Yeah, and reliability is always at the core of anything we do in substations. And of course, if you're going it together with others, the 61850 way, you're safer in that sense. But not necessarily faster, better, but
yeah, I agree. So if we go back in the history, I know you started with IEC 61850 really early. Can you tell a little bit of that? When did you start?
Yeah, when we decided to have this talk, I was trying to check my records. When did I really start? I found early traces from like 2007, 2008, when I was experimenting with using it, but the first proper record I found was from 2010 when I had some material in a course here.
Okay.
It could have been earlier too, but I couldn't find it.
But
in
more
my
like
hard
experiments
drive.
maybe. Yeah.
So it's close to 15 years, and I started because I needed a good framework. Well, that's a terrible word, but I needed something to bring to the students because you can tell students that, well, this is a relay, this is what it does, and they will be like, okay, sure, but you would like to have something, some sort of framework for it to fit it, and then the 61850 standard popped up as a really good teaching tool, really.
Good. And how has it developed from when you started through the years and so on to now? If you see the changes, what did it start at? What did you teach? And then, something about that.
Well, in the first parts, we were focused quite a lot on communication, perhaps reasonably.
Yeah.
I mean, looking at goose messaging to send trip commands, etc. At that time, wasn't so much sampled values around for the merging unit, so goose and a bit of MMS.
Yeah.
But gradually, it developed into a more large body of teaching and so on, where we also went into using the SCL, the system or substation configuration language. I keep calling it the substation configuration language, where we had quite a lot of work with that too for the students. So it's been growing, and then going also adding a bit of practical work with it. So we've had many flavors, and then recently we've been streamlining it a bit because the standard grows and it's very difficult to cover everything.
Yeah, I understand. As a student or as a course, you need to just touch base on many different subjects. So this is just one of them, I guess.
It is indeed. Yeah.
So how many students did you have from the beginning, and has it changed over the years, going up or down? Or?
It's been going up and down. Right now in the classroom, there's around 40 students that take this course when I have the 61850 parts. That's more or less as it started 15 years ago, but then we had a bit of a dip down to 20, I guess 8-10 years ago. But now the recent focus on electrification and sustainability and everything has really
so it's popping up again.
It's popping up again for sure.
Good. So that will be like some 400 students have been
something like that.
Good. So a question, why should students learn IEC 61850? Maybe stupid because we just talked about it, but anyway, what do you think is in it for them?
What's in it for them, Well, it's a good question because, what you normally study at the university is, mathematics, physics,
Yes.
theoretical topics. And then when you come to the later years, you apply those theories to problems. You may have studied a lot of control systems, and then you do some work on automotive applications or something like that.
Yeah.
In this case, what I'm trying to teach is a bit more of engineering work, good practice within engineering.
Yeah.
How do you build a digital substation, or how do you build the substation of the future? There's no core mathematical theory to explain that.
No.
It's just we've done it like this, and it seems to work. And thousands of engineers' hours have been put into
Make it that way.
Make it that way. And it's always difficult to teach a person experience. You can't teach someone experience, like you can't tell your 14-year-old that someday you're going to be 18.
You can try,
you can try, yeah.
Yeah.
And the same thing, of course, it's very difficult to teach a student here, this is how you build a substation. So the 61850 is perhaps, it's a way to bring packaged experience to the students. We can show them that this is how substations are designed. This is how you connect things. These are the information models used. These are the protocols that are used. These are the devices.
Yep.
So that they at least get some feeling for what they can expect once they're out in the real world. Yep. You could say that 650, well, it takes the place of a theory. Let's say I was teaching physics and I would need some mathematical foundations to do it.
Yeah.
In my case, I'm teaching digital substations, and I'm using 61850 as the foundation to build it upon.
Yeah, which is built from experiences and a lot of thoughts put into it. So yeah, it makes sense. You touched on it before, but how did they get a practical experience?
Yeah, that's the best part of any education is to do some practical work.
Yes.
But it's also the most challenging to have, at least here at the university, to be able to bring standardized, easy to use digital substation practical experience. Because again, I'm not a practitioner. The students, they're definitely not practitioners. So I've had this experience that you want them to learn, let's say, how a goose message is sent for a trip.
Yeah.
And you need to do a lot of configuration. You
Yes,
need to configure this and this and that, and this and this and that, and that and this and this and this. And once you've done all that configuration, you press a button, and the goose message goes across.
Yeah. Yeah.
So, and then a little LED changes color.
Yeah.
And for the student, it's like, what was the magic here? I was like filling in a lot of fields in this machine, filling in fields in this machine, and then, okay. So the learning experience is not that exciting, really. And that's a bit of a hurdle, because you would want them to at least see what it is, but in the end, it's not that exciting. So it's really important to balance it.
Yeah.
You need some sort of practical experience for sure.
Yes.
But you also need to make it at the level so that you can get to the point right away.
I understand. It may not sound so interesting to lit up a LED after a few hours work. Yeah. But on the other hand, that is also reflecting reality, right? I mean,
in a way, yes.
So you have a lot of work that you have to prepare to make it work. But when it works, it works. It's kind of that way.
Yeah.
Have the practical part, has that developed over the years, if you see from the start to now?
Yes, that's definitely changed a bit. And here I guess I've been also learning a bit that we started out quite ambitious with the exercises like the one I gave the example of. But it turned out that for us to maintain it and the student work, and in the end we just lit an LED, it turned out to be a lot of overhead for little learning.
Yes.
So we scaled that down and had some more prepared like recipe things where we for instance we took Wireshark captures of communication networks, so that we could show students that this is the traffic that this type of event would cause and so on, and then they had to explore that data a bit. So we did that. We've also been working, as the course developed, into using the SCL.
Okay.
We were using a tool called Helix, which is this vendor-independent configuration tool for
top-down engineering.
Exactly, and that sort of this top-down approach that has turned out to fit quite well for the students, because that's what you can. Then you don't get stuck into the very minute details of stuff, but you can start with a one-line diagram.
Yeah.
You can add devices, logical nodes, and so on. It's a bit of drag and drop and so on, and then of course you get to the configuration point, and that's again where it can really explode into details, which the students are going to be baffled with.
Yeah.
So that's what we've been doing too. That has worked well, and then we're continuing to develop that further. To it's a matter of meeting the students where they are. They've never seen anything of this before.
Oh, that's true.
They have no clue. They've
Easy
never,
to forget.
I mean, they have no idea. They've never been in a substation. They don't know what is old, what is new. They don't know nothing. So you need to bring it to them in a careful way, not to scare them with strange configuration details. But at the same time, you can't leave it too abstract, because if it's just slides, people say, okay, nice slides.
Yeah.
They don't learn anything either. So.
Yeah, you need the balance, and I guess you learned over the years, maybe too detailed sometimes, and then taking
it's
it back.
a bit. And at the same time, the standard has developed.
That too.
So it's like
moving target.
It's a moving target, and it's a group of people that you really need to find where the level is. Yeah.
I mean, the electrical engineering is so broad, so they can do practically whatever they want, the students, when they. But if you recall a few which have been really into this digital part, what will they typically become when they graduate and come to the professional life? Do you have a few examples there? Yeah,
I have a few people in mind, and the early. When I started out, the first, let's call them graduates from these courses, they ended up in R&D with the utilities, etc.
Yeah.
Because it was really an R&D thing
at
that
that's
time.
True.
Yeah, pilots and stuff. And some of them are still there, but some have moved on. Now I see that most those that are really keen on these topics, they end up working with the engineering consultants generally, because it seems to be a very sought after type of skill.
Yeah, can imagine.
I mean, in refurbishment of substations, they need people to work with 61850. So they end up as free agents in that sense.
Yeah, exactly. Yeah.
Which I guess is good, because that means through their work in very different utilities as consultants, then I guess it can spread even more.
Yeah, that's true. They face many different situations, good for them and good for the industry, I guess. So you say that many go to the consulting business today, but how do they get more education and more insights within this then? Because they need to charge per hour and so on, so it's difficult for them, or how does it work?
Yeah, it's a really good question. And I think in general, when there is this new type of technology, let's call it 61850, that you would like to roll out over society, consultants are a good way of doing it, because you have these experts that work in different companies. But of course, how do they develop themselves? And I think we've been fortunate here in Sweden. Quite early, there was a 61850 network started by some enthusiasts, and then it's still being maintained by Energiforsk, the R&D branch of the utility companies. And they're setting up regular meetings, sharing experience and so on. And that's grown now to attract people also from the Nordics and rest of Europe, Italy and so on, to participate and learn and share experiences, which I think is a really great way to build this momentum. And of course, I'm there now and then. We can talk about some new things we have in our course, or some project that some students did or so. So it's, I think that's the way to develop it. Yeah,
that sounds good, actually, that you get that knowledge from experiences, learning from what others do and so on. So
and that's again what 61850 is all about. It's like this body of experience.
So do you have any projects running currently? What projects? I guess you have projects or research or anything. Anything? What's going on right now?
Yeah, what's cooking? Yeah, it's a good question. Yeah, we have very interesting projects for sure. I mean, again, coming back to this being an industry which is really developing fast.
Yes.
61850 is not a topic for research. So that's the projects that I do and my students do, they are generally not related to like develop 61850. It's more that you take a digital substation, possibly 61850 as a base, and then on top of that you develop some new control algorithm, or you do some data quality checking, some clever little algorithms where you can take 61850 as a granted thing.
Foundation.
Yeah, because again, 61850 is experience. You can't do research about experience because So that's a bit split in that sense. Comes back to what you do at universities. You develop theory, which is 61850. It's not theory. It's something else. But I think still it's important that when you start here, for instance, as a PhD student, you know a bit about the real world in the sense of what 61850 does for you. So, but the projects, they're good and interesting, but not 61850. Really.
Oh, really?
Yeah.
So that means that you haven't in the past either seen projects which have been very successful here that developed, or have you such examples?
I mean, we've been doing, let's call them, some advanced studies on how could we use 61850 across a wireless network. What are cybersecurity threats to 61850 substations? So they're interesting studies, I would call them, where you pinpoint a weakness, or you show that, well, it would work under these circumstances and so on. So that's a bit, but these, again, that type of study can just as well be done in the real world outside the university, because it normally requires that you have a lot of equipment set up and connecting things and do a lot of engineering work to then test this thing, which is quite resource intensive also for us. So,
I understand.
But there's been some papers published and so on this for sure. But
And is there anything in particular that you know the industry acquired it and adapted and implemented it because it was really good, or is it too early to say maybe?
It's, I guess, too early to say. I must say that with regards to that, I'm more happy about some of the PhD students that did work 61850 related. They are now in the real world doing really good work based on the knowledge they gained. Perhaps not on this brilliant research paper they wrote. That's not really what anyone wanted, but the knowledge they built
and that's
in their own heads.
That's true. That's what's really driving the business forward in general. So what engagement do you have with protection and so standards, both personally and also the KTH in general?
In general, for standardization work, we're very welcome from academia, so it's quite easy to get engaged. And I must say I'm surprised that not more of my colleagues are engaged. Personally, I've been involved for many, many years in TC 57, the local committee here in Sweden, the national committee. And that's also been an really rewarding experience from meeting all the experts in the committee, of course. So that's been really good. And then I've seen some other colleagues that have done similar efforts, not massive. I don't know, perhaps they don't see the benefits of it, or if it's the time. I did, however, experience that as part of my work in the standardization committees, I don't have an agenda. I would assume that most people that represent the company, they have one agenda or so. They would like the standard to develop in a certain way because it's true,
to benefit
with the products they have, which is perfectly fine. That's the whole idea of the standardization committee, is to create some form of consensus. As a university professor, I don't have an agenda. So I realized when I came to these meetings now and then that I might as well shut up here. Because if I push some idea on how things should be, I don't have a vested interest. Let's say I push some good idea, which is really costly for some companies. I'm just creating a problem.
That's true.
Yeah, because we are not building a beautiful theory. We're gathering experiences and agreeing on a middle ground.
Well thought. Yeah, good. And how do you and KTH cooperate with the industry?
Yeah, that's a key thing for us here at KTH. I guess it's always been. I mean, the most low-hanging fruit in the collaboration is really the students' master thesis, the thing they do at the end of their project, where a large majority of the projects are really together with the company.
Yeah.
The best such projects are those where some teacher here, me for instance, have already a long-term relationship with a company where we have been developing something together, and here comes a student along, and we can together shape that master thesis.
Yeah, that's true.
So it combines the interests from the university with the interest of the company,
Yes.
and the student, of course, can also shape the content of it. So that's really a low-hanging fruit. And then, of course, on top of that, various research projects, which are then partly funded by industry, but usually also very much by various government and European level institutes like Energy Agency or Science Council and so on. And that's kind of clever from these government funding, that they're saying that we'll fund a part of your project if you can also secure another part from industry. As a way of ensuring that we're not just doing that we connect. Yes. So and it's also, well, for me, and I think for many of my colleagues, the most rewarding projects, because you can really see that someone is interested in it. I guess that's throughout engineering. That's what you want to do.
You want things to get used and get benefits, of course, in the end. So
exactly.
I understand that part.
So that's important.
So if we take the last part with the future, it's always interesting to have your crystal ball and predict. And I think as being in a university, many times you are in the forefront to some aspects. What do you predict in the short term for the industry in IEC 61850 and so on? Where will it take us?
I think now it has gained so much momentum, so it will rule the world. I don't see it being. It cannot really go away. It's been. It's
gone too far.
It's gone too far now, which is a good thing. I mean, so it's really happening. And another twist to it, I think that with standardization and digitalization, you also open up the domain to new companies. I mean, it's always difficult to enter into the power industry as a small startup, because there is so much legacy and reliability focus and so on. But with open standards, open source software, easy to access data and communication protocols, you can quite quickly develop new prototypes which you can show to customers that would challenge the incumbents. So our technology is also 61850, but it's 10 times as expensive. And that, I think, is something which we will be seeing more of, where substations become more, well, let's call them flexible or configurable, because of competition from new companies. And that, I think, really is something we can see more of.
Yeah, I agree. And if we see really long term, like decades away, will we have the fully intelligent system running with IEC 61850 everywhere and so on? What's your...
I think if we look at it from the other perspective, considering the changes in the power system that we all see around us, the variability in production and electricity prices going up and down, and the emergence of markets. There's markets for flexibility and markets for congestion and so on. That must lead to more measurement, more control, more automation. Otherwise, there is no way of operating this system.
Correct.
And at the other end, we saw that 61850 is not going away. It's definitely growing, and we have an increased need for automation. So for sure, a decade away. But then speed in this business is
it's conservative,
it's
and you
conservative
need to try
industry,
it out 2 times, 3 times before you're really sure.
But that also is some of the development is shaped by industries which are not the power industry. I mean,
that's true.
The battery providers, the EV providers, smart homes, etc. Which is a much faster industry dynamic. Which is to some extent pushing what the
So the
utilities-
speed will probably increase from that perspective. Other actors will go in and take over. I
Yes,
assume.
it could be.
Who
I
could
mean,
be
in some
faster.
abstract sense, perhaps you could say that the utilities will be requested to provide an API to the grid.
Yeah.
Well, in some abstract
Yeah.
sense, it's not just a coding thing, but and that API to provide data transparently to consumers and producers could be a 61850
Yeah.
API.
Yeah, interesting. And if we change from the industry to the academia instead, what do you see short term here?
Yeah, well, this is an interesting question. I mean, we are definitely right now in a bit of a boom where there is so much development happening in the power industry. Almost all our projects now are related to how power electronics will change the power system, moving from a physics, electromechanical rotating system into an electromagnetic fast switching power electronic systems. So it's an enormous amount of projects that go into the stability and control of a lighter system. We don't have rotating mass, we have control systems that define our frequency and voltage.
Yeah.
And those control systems, they must interact, they must collaborate, they must be secure and robust. And here again, 61850 could have some role to fill.
Yeah.
It's, the business is, as we know, a bit divided. We've had people that work with SCADA, we've people that work with protection and automation. Those two worlds have kind of met.
Yeah.
And then we have the whole world of converter and inverters and power electronics people, which is a third perspective. They don't necessarily think 61850 is the best way for interacting between inverters, but they should.
They should. I agree. Yeah. And if you think longer term, maybe that's difficult for academia, but well, do you see any direction you're taking or how this will evolve for academia in the really long term or decades?
Well, I think a challenge I see today is that when I teach, for instance, 61850, I tell the students this is the way the digital substation is right now and so on. And then when they go out into the real world, it's not true. Because there aren't so many digital substations.
That is true.
So they're like, okay, what did the professor say? So, of course, then, looking far ahead, my courses will not be that exciting in that sense, because I'm just telling them, well,
this is what it looks like.
Yeah, it does. Yeah. So what's the news here? And of course, the knowledge they bring will not in the same way will be changing the industry 20 years from now. But of course, still, it's going to be exciting times. And by then, I think we will be so much more focusing on the application end when we have a combined power and communications infrastructure, and this API idea perhaps, where we can focus on
that part.
The control from a perspective, which data can we receive from neighboring substations, what do we know about the production which is connected locally, what do we know about the overall situation in the grid, and which decision should I take in my substation or in this microgrid to optimize my use.
Yeah, it sounds interesting. We hope you are there to see what we created in the end. No, but it's really good. Yeah. Thank you so much, Lars. It's been a pleasure to be here and talk to you and hear your insights about what KTH role play and so on. So it's been really a pleasure.
Yeah, well, thanks so much for coming or having me. Yes, yeah.
Okay, and this is the second episode, and we will now look for the third episode, and we have some ideas. But again, if you have ideas out there that you like us to talk about, please share it to us, and we will see what we can do. So thank you so much for today.